Hello, everyone. My name is Marcella Walsh, Live Content Coordinator at AVIXA, and welcome to the November Smart Buildings Power Hour. Today's topic is energy. Joining us today is Bob Snyder, Editor-in-Chief, Channel Media, and publisher of Smart Building News, Digital Signage News EMEA, European Solution Provider, and more. For the past 10 years, he has been the content chairman for the Smart Building Conference at ISE. Before I hand the presentation over to Bob, there are a few housekeeping items. For those viewing live, today's webinar qualifies for 1 CTS and CTSD RU credit. Please allow 5 to 7 business days to view on your transcripts. For any issues, please email webinars@avixa.org. The webinar will be approximately 45 to 60 minutes, and all attendees will be placed on mute. If you have questions during the presentation, please enter them into the Q&A window so that Bob can address them at the end of the webinar. To access the Q&A window, simply move your cursor to the bottom of your live stream video box to locate the Q&A icon and click to open. Please do not enter your questions into the chat window. You will have access to this recorded webinar at avixa.org/webinars within about 5 business days. And now I will hand things over to Bob. Take it away, Bob.
Hello, everybody. Welcome. Thank you very much for joining us today. And we'd like you to be able to ask any of the questions that you want of our experts and to enjoy the 4th in the Smart Buildings Power Hour series here at AVIXA. Before we start, I have a couple points that I just want to repeat, as I usually do at these sessions, that our topic today is energy. But everything in smart building is connected to everything else. So we cover a lot of things that are not just energy, but we would like today to highlight the energy side of the smart building equation and to bring you some insight into it. And our speakers represent different points to address towards it, and a lot of things that go beyond energy as well. So, but we'll get into that. The series that I'm just trying to move the slides forward here. There we go. Sorry. The series, the Power Hour Roadmap, covers a lot of different topics, and as I mentioned, they're very connected. We're now moving along to the next Power Hour, which includes today's experts, and I'm very pleased to introduce this group. I'd like to introduce first Cher Houston, who is the founder and CEO of Clevair, and they enable legacy buildings to become autonomous. They prepare for the weather to come, adjust conditions for people in the building, and optimize all parts of ventilation, heating, and cooling in the building. Cher has a master's degree in industrial economy, and his last startup went from 0 to 10 million euros in 3 years. He has been the founder of Creator Makerspace, and in 2012, he built his own 3D printer from parts, for which I give him a lot of credit. And he's also the founder of the Startup Weekend in Norway. With more than 10 years experience in the voice over IP world, he's been one of the founders of one of the largest white label operators in Norway, and has become part of a project focusing on VoIP security and frauds. He even built his own first LoRa gateway in 2016. So we're very happy to welcome Cher to the talk tonight. We also have with us Derek Coburn, and Derek Coburn is the CEO of IlluminCache, and he has 25 years of experience in commercial and residential building and management experience. And Derek founded IlluminCache in 2012, and his invention is based on what he saw as the greatest transformation occurring in building technology since the internet and the power grid. So we're going to hear a little bit more about that. In a category by itself, Lumentech is not specifically, power over Ethernet lighting, and not specifically 24 volt or 48 volt DC. It's an open platform that adapts to new technologies and standards. They've been operating in projects around the world since 2012 and has scaled up to meet the demands of home and office builders. Derek also, by the way, spent 6 years as an award-winning AV integrator based in Indianapolis and a product development manager for Rockwell Automation, and now lives in the electronics manufacturing capital of the world, where it's a very wee hour in the morning. Derek, thank you for joining us. I'm also introducing our third expert, Elizabeth Nelson. She's the co-founder and head of innovation and living labs at Smart Building Certification. And they're helping the industry by designing certification to award buildings that have the infrastructure in place to measure a building's performance and behavior. She's the head of UpLab, which is the research arm of Up There Everywhere. It's a business transformation consultancy handling everything from market research to industry analysis and expert panels. She's a PhD candidate and just finished her dissertation on wearable technology. And originally as a writer and a biomedical engineer, Elizabeth, her own battle with corporate burnout inspired her to be a pioneering scientific researcher and to launch a crusade to transform the office ecosystem. And she's the author of the book, The Healthy Office Revolution. Thank you for joining us, Elizabeth. The start here, I want to just keep addressing energy for a minute here, because energy is that #1 driving force, that's been pushing smart building adoption. It's been the driving force because it's been the easiest thing to appeal to the stakeholders, to the owners, and to the landlords and say, look, you can save some money here. It's a lot easier as a sales point than telling people that they're going to help the world, they're going to help their employees, they're going to do all sorts of good. This appeals to their pocketbooks. And in the end, smart building is a business, and it's been a big motivator. It turns out that a lot of that energy in the buildings isn't even necessary. It's been wasted. And for example, Berkeley Lab, which is funded by the Department of Energy in America, their study showed that across 6,500 buildings in America, they were able to save $95 million a year just by applying some data analytics and some smart energy formulas to it. So this is the direction that we want to look at, because commercial buildings have been using 30 to 40% of the energy consumption in the country. And it's expected with the change in the climate to rise up to 50% by 2030. If the US could reduce that commercial building energy by 20%, and most people feel that it's possible beyond the 20%, it'd save $80 billion of money in energy costs a year. So the goal, the dream is net zero, where every building provides as much energy as it expends and nets out. And of course, not every building is ever going to get there, but it's a goal, and achievable in different stages for different buildings, and achievable in different parts of the building for different buildings. But if that goal is to be reached, we have to have new projects, new products, new technology, and this area of smart building is expected to hit 1.4 trillion by 2035, according to my friends at Navigant Research. And one other factoid to bear in mind is, where is that energy use in commercial buildings? And lighting is about 20.8%, cooling, ventilation 21.2%, heating 26.1%, office equipment 5.8%, and other 26.1%. And this is information provided by Lutron. The use of energy in a commercial building, obviously there's a lot of savings in lighting. This is one of the things people want to concentrate on. Also predicted in cooling and ventilation, a lot of, I don't want to say easy savings, because nothing is easy, but the prospect for savings is there, and is what
I'll just shoot in a little bit here. We have people from
Sure,
Dubai
sure.
with as well. And they have about 65% is cooling of energy usage in the buildings. So it's a US centric.
65%.
Yeah, in Dubai or like in Middle East. So it varies a lot. And of course, in
Yeah.
Norway, you have a lot more heating than cooling.
I was going to say, I'm from upstate New York, and we need a lot more heating than we do cooling. Again, this number is particular to the United States market. That is correct, and it's a survey of commercial buildings in America. And again, it does change according to region, and thank you for pointing that out, Sure. So one of the big problems is, is not just, having some data on the energy, some insight. The problem is transforming data into actionable insight. And one of the things that was discovered is that letting the occupants in the building also know what's going on actually is a very helpful way to get people to adopt change in their life and to contribute to it. I want to open this up to discussion because my experts are the ones you really want to hear from, but I want to just underline the driving technologies, some of the things that are changing what's happening in the space of energy inside of smart buildings. And I probably should have put on big data as well, but it's the same technologies that are popping up in a lot of industries at this point. It's the cloud. People are coming up with ways to improve. For example, there's a company in England that supplies a cloud software that monitors where and how energy can be saved in the building and actually ties it in with availability from a smart grid. The Internet of Things, which is also related to edge computing, providing the sensors and the ability to think and to capture data and even actionize some of the data at the edge of the computing network. Artificial intelligence, companies who are using artificial intelligence to make predictive behavior. And of course, the general smart grid, which, because it's smarter these days, is allowing us to have some opportunities to work towards that net zero that we mentioned. That's my introduction on energy. And I wanted to go from that quickly over to Derek, because I think Derek has something to share that will, I think, underline some of the points we want to make. In the future, this is one of Derek's slides. The future is not about one standard, but the ability to adopt any standard. And Derek, maybe you could start off and tell us what you're doing, why you're doing it, how it fits into this picture of energy and lighting. I'm going to stop sharing my slides now so that we can join in as a panel. Go ahead, sir.
Sure. I mean, thank you for the introduction, and certainly the kind of getting everybody to speed as far as the energy topic today. I loved some of your comments because, I've always joked that if you want to make buildings really efficient, you get rid of the people. It's not very practical, but the reality is, people we build buildings for people, and they are going to consume energy in there. But as many people have said in the past, energy savings is the first fuel, right? So when you want to, we struggle sometimes to keep these grids alive from the demand that we put on them, and yet keeping them alive and avoiding blackouts can be as simple as 10%. That's it, just shedding 10% of that load, and it's enough for the existing grid infrastructures to stay in place. So I got a kick out of your one slide that was showing a 60% savings in lighting energy, which you can definitely do from incandescents down to LEDs. But and it was for sure Lutron who was showing that big savings there. But the reality is nowadays we're starting to kind of squeeze the last little bits of drips of energy, and at the same time, you have energy costs that are dropping because of renewable energy. I mean, solar panels are so inexpensive nowadays. Once you add the batteries to them, you pretty much have, very low cost, locally abundant electricity. And depending upon the type of industry and office and building you have, sometimes that's sufficient. So, I loved your comment about net zero energy, although my notes I was making was that the community, net zero community with the DC microgrid, for example, is a little bit more achievable than a net zero home because of the diversity of use in each home. So, so hopefully that'll give us some first topics to chat about.
Thank you, Derek. And we're going to go back and forth here a little bit, but I think maybe we should talk to Shure first, and then we'll come back to you, Elizabeth, because I want to underline the certification side of it. But Shure, maybe you can explain to us a little bit about Clever and what you're accomplishing.
In very short, we target the existing buildings, and they're challenged, and they're running statically, as we call it. They go off 6 in the morning, go off 6 in the evening or late night. But now, like Derek also said, the best buildings are not run by humans. But then what we do is just, okay, look at the weather that's coming, how many people are in the building, and we just help the local system to actually adapt and to improve the indoor air quality while not wasting energy. So it's really like, I would say existing buildings today, they are like a car where you drive from one city to another with a fixed gas pedal. And what we do is we just take that gas pedal and throttle it up and down, and then we see weather, okay, it's coming hot weather, okay, then you can throttle it down before the weather is hitting you, or throttle it up because it's going to be very cold or other stuff. So it's making autonomous buildings out of the existing building that is. So it's just bringing the intelligence into it, and I'm amazed how terrible it actually run, because you save 20, 30, 40, even 50% in cases just because it's not set up correctly, and either they don't have the manpower to do it or they don't have the competency, and that's really the big challenge. So it's just really put it in a system and make the building make its own decisions, and it runs so much better.
All right, thank you. I'd like to now, at this point, Elizabeth, ask you just to explain what you're trying to accomplish with the smart building certification. And of course, that relates to the energy side as well.
Sure. Yeah, I think to sum it up briefly, I think what we're trying to do with the smart building certification is really do a certification that pushes the industry a bit. Real estate is not always the fastest moving industry, to say the least. But we thought, what if we could do something that really was affordable, a certification that could be also available for very small buildings or old buildings, and really acknowledge this is an old building. It cannot perform the way that a brand new building can, but it should be acknowledged what it is doing, and then actually measuring the technology in the building, but also the impact. Can we make safer, healthier, more sustainable, higher performing buildings with the technology? We all think about technology as the end game with smart buildings. Sometimes it's just the beginning, right? It's what we do with it. And yeah, we absolutely still need some human computer interaction, or human interaction with all of this, because we just don't have the systems set up perfectly. Although, like Shure said, once we get it running, a building can be so much more efficient when it's actually properly installed, when the sensors are working, when everything's put together. So smart building certification is really trying to be a bit disruptive in this area, to do something that's available to everyone and hopefully raises asset valuations. That's one of our biggest goals, is to actually get the first smart mortgage, and also to get raised valuations for smart buildings. So that's in a nutshell.
I would love, Elizabeth, that all our customers had a certification or went through their buildings, because we find errors in every building we go in. There's always and it could be really grave errors. Even one building, we found a physical hole in the ventilation system by just analyzing the data, and it's crazy.
Well, it's crazy how much people don't get involved with their data. I think, to have these very expensive sensors and to just be able to have someone who knows what they're looking at, look at it, it really can be quite a clear what's going on.
But it's a deal to get just to make a list of all the equipment they have and go through it, like just a checklist, and that's part of the certification, as I understand.
Yeah, definitely. Yeah. So one of the things that we're also doing is we're certifying some dumb buildings for buildings, because it is so affordable. I don't know if is that PC? Is that not PC? Dumb buildings? But just to show what capabilities they have and what they can do in the future. We're also certifying buildings that companies are thinking about buying to see if it's a good investment. Some people say, buy our building, it's smart, but it's so theoretical still, and it doesn't need to be.
There was two good examples, just wrapping our heads around these two things. One of them was, I got an opportunity to hang out for a few days with Amory Lovins at Rocky Mountain Institute. Now, if you know about RMI, it's extremely low energy building, right? And so he kind of told me a little bit of the background of the building, and then he gets some things there gifted. One of them was a building automation system package that monitors all the energy in the house. Well, it turns out that the BMS system was consuming more energy than the house was. So that was one thing. So it's really important to note that sometimes all of the overhead we were just talking about with the cloud computing and everything else needs to be applied very carefully, because you can actually be consuming more energy than you're saving sometimes. And so, the ability to take Shure's package, for example, analyze and then kind of move to the next building, stuff like that, come back to it again, that really helps. Another quick example was something very close to home, my own parents' house. There, we designed and built the very first Lumen house, and they lived in it. And it's got geothermal, and it's all built to passive house standards, very, very low energy. It costs them $10 a month in electricity. It's the connection charge to the grid, right? So, but my mom called me up last winter and she said, we just got a $400 electric bill. Like, something's definitely wrong. And I was just arriving there the day after. And so it turns out that the PC board on the geothermal furnace had gone bad, and the system was in emergency heat for a month. So you can imagine, in 1 month, it churned through more than a year's worth of energy. And so, that's a perfect example where not enough sensing or not enough indication is also a bad thing. And so there's a balance that has to be struck. If you have every single new building has a tiny bit of monitoring capability, it doesn't have to be a lot, but that will truly save us, all of this energy. And sometimes it's simple little things like, a piece of a product failure, or we had great conversations before the meeting started about, things not being connected and installed properly, et cetera. So every piece counts. But
Derek, I can add on to that one with just get an inventory of what's in the building already. So we're sensor agnostic, so we can take in almost any sensor, but we actually see that there's so many sensors already, and there's CO2 sensors in the meeting rooms and so on. Then we can estimate the number of people in the meeting rooms and how often they are used and so on. So for those people on the call here, if you want to start doing a smart building and so on, it's get a list of what you have in the building already. What sort of systems do you have? Could do a certification, then you get the help to do the list and so on, and then see where your gap is. That's just use what you have.
You mentioned, I talked about the motivation behind my product in monitoring, and it came from, I started in building automation systems in a big 50 building pharmaceutical campus in 1988. And at the time, we had union operators and union mechanics who were running these systems. We were converting the old pneumatics into DDC, and there's all the dynamics of the battle going on for that. But what I was seeing was all of this expertise retiring, dying. All this experience was going away. And these guys, they would look at the newspaper and they were looking to see what meetings were going on, what the weather was going to be. They'd go out, they'd tweak a few valves and come back and sit for the rest of the day. And it was brilliant. And, that level of experience, I think, can be learned. And so the machine learning algorithms and these kind of tools can do the same thing, but they have to have the sensors. These are guys that could walk around and smell and hear and feel. And so the types of sensors, you can get a lot of sensor fusion from certain types of sensors, much more so than trying to monitor every single little input. Elizabeth was talking, and Shur was talking about how, these poor building operators are getting bombarded with data and they don't know how to analyze it and what to do with it. You need a computer almost to be able to analyze that much content.
Yeah, I would start in the other end. It's we had customers that came to us and they got another offers like, oh, you need 100 or 200 sensors before we can give you any insights and so on. And we just went back to them and said, hey, just start with what you have, get the information flowing of all the equipments, get them connected, see what you have, then write the use cases. What do you actually, where's the problems today? Where do you want to go? And then close those gaps. I wouldn't go and buy lots of sensor packages and fulfill the whole house before you actually know what problem you're solving. And that's also back to the ROI, which is very heavily in this industry, is everything has to pay back.
Yep. And it's funny because embedding a little bit of sensor into the power delivery, that's what we ended up doing, because we just basically said, well, everything needs to have some kind of sensing, but it's hard to justify the cost of all these things. And so by just kind of having it available as an underlying infrastructure as part of the power system means it's already there, and AI can now take action on it too. So it can actually control things and then say, oh, that's interesting. When I do this, this happens. So, having a whole new foundation in a building that does have sensing kind of built in as part of it will enable all the kinds of applications like yours to be able to look at and do things with the data.
I should have added at a certain point that according to research in America by CoStar and similar research in Europe by JLL, James Lang LaSalle, the payback from solving the energy problem in the buildings definitely results in a higher premium value on the rent and the duration of the contract, and also has payback in terms of the value of the property. And this is one of the newer ways to get the attention of the stakeholders to create action in that. I have a question from one of the audience. I wanted to throw it in at this point because I think it's an important part of the theme of what we're doing. And then I want to come back to what Shur and Derek, some of the things that you mentioned and how it relates to the role of integrators, and also back to Elizabeth about the certification. But let me raise this question from the audience first. It says, do any of us see a trend or any equality to the progression between smart buildings and well buildings? Are we adding these sensors and automations, increasing our energy as well as other resources? Can we achieve both? I think that's a question. I'm going to give it to you, Derek, first, because I think you're eager.
I was just going to say, and I'm actually lining something up for Elizabeth here, because it's funny that, it gets back to my joke earlier about if you want to make a building, get rid of the people. But the whole point is that if you make a building, so efficient maybe that it's uncomfortable, you're defeating the purpose of the building. And, what's the rating for that, right? If there's got to be some kind of rating system. And I thought about well, and then I looked at the question. So thank you, Alex, for asking the question. But yeah, well buildings to me is one of my favorite certification processes because it has to do with the most important element. How happy are the people inside the building? And if you can take that and turn that and monetize that and say, well, actually, what's the value of that? What's the CapEx return on some particular nice feature? So hopefully Elizabeth can add the rest of the answer here.
Oh, I love that. I think it comes down to, if we have, the smartest building in the world, for example, and it's not the best building in the world for the people in it, for the purpose that it's driving, then it's a huge failure. It's not smart at all. It's just wired up with some interesting technology. So
You can
yeah,
certify it as a dumb building.
yeah. Or, yeah, maybe not. But yeah, I mean, a smart building, if it's not a healthy building, what is it? Maybe a factory, but or a storage compartment. But some of those are actually more environmentally controlled than the places that we work in. But yeah, I think sustainability or health sustainability, those elements also come into the technology within buildings. So we address those aspects from the technology point. We don't go as deep as well. We don't go as deep as LEED or BREEAM, for example, but we do really also look at the individual's experience with the technology. So when we were talking about data, I also think, put the data out there. If you have a great high functioning building, prove that you're safe for COVID. Show that you have a great occupancy strategy for how people move throughout the building or work throughout the building. If you have great health standards, definitely show those, because I think people that you walk into some smart buildings and you hear, "Oh, this is a smart building," and you go, "Okay, where? Let me see." So yeah, I hope that COVID really pushes the kind of feedback and being a little bit more open with some of the data in the future.
Yeah.
There's
I'll, I'll,
some
I'll
yeah,
add a little bit to it on I agree on the person is the most important in the building. But it's quite funny. We, like in Clever, we take 5, 10, 15, 20-year-old building and connect to it. So we have a lot of protocols and stuff that we talk to. But I actually got a BREEAM certified building that was just a standard building. And we connected up, got all the data from it, and then we just gave them the insight they needed. We just used the Wi-Fi, the technical network, and so on. Then you could see all meeting rooms in use, how many people on each floor, and so on. So you just added the smart building on top of it to give them the insight on how to use it. And on the certifications, it's the user and the user in centrum. Like, how can you make the building even better? Why are they not using these zones? Are they doing all right? Why are they not used? Yeah, and so on, and improve it.
Soft costs is a big topic, right? Because they're harder to prove. Sensors are really easy. They give you, retrospective view of what exactly happened. But being able to predict what's going to happen in the future of the building is actually more valuable, but it's harder to do. So, that's why I'm more excited, and I'm turning it back over to Elizabeth again, because I think you said something about like smart mortgages and things like that, and also the insurance industry, right? I mean, the insurance industry on buildings nowadays, especially with the storms and everything else that's happening, they've got to be having a huge amount of interest in what we can achieve, and are probably looking forward to some kind of answers there.
Yeah, I think finance is the kind of the best way to push forward. We actually did a mini conference yesterday with smart building certification, where we brought in a couple of banks and a academic who is an economist who studies the impact of smart buildings. And one of the things that was really kind of shocking is they said that we're quite a bit closer to smart mortgages than we thought. And COVID has certainly pushed that forward, but possibly, a year to 2 years away from having our first smart mortgage. And I think there's some key areas that'll probably go first. The Netherlands is an area that people are betting on, the UK, Germany, those kind of maybe some of the Scandinavian countries. But with sustainability kind of back on the global agenda for next year, I think sustainability will also be something that's brought in. And I wanted to touch on something that Bob said earlier, because you were talking about net zero, but there's also net positive, right? We do have buildings that are creating more energy than they're using. And I think that should be talked about more and celebrated more, because there's not a lot and it can't be done by every building, but yeah.
I think that'd be also great for individuals in the society today, net positive. I kind of like the concept. I have another question from the audience, and let me read it first, and then sure, I'm going to turn to you, to answer this first, but they're asking, and I had it on our agenda anyways, is how will things change, in terms of energy with the mass, switch, in the paradigm where there's a lot of work from home during, the pandemic. And sure, I think you have some thoughts on that, so I'm going to give it to you first.
Yeah, in my we got a lot of customers, training centers, so on, because of on demand, because there's a lot of more fluctuation and the building in general is less used. If the building was packed every day, yeah, ventilation had to run 100% and so on throughout the day. But now with more sporadic use and so on, it's even more important to save the energy while the people are not there. That's the energy perspective of it. If I pull a little bit further, the commercial real estate, like those that are renting out offices, there's a shift in mind, in my opinion, that the office needs to actually prove that it's that you have a reason to go to the office. That they did a survey where how many days do you want to be in a home office? It was a Norwegian survey, and it was like tilted on the home office, most like 3 or 4 days a week, and then the office. So the office actually needs to prove its value. And then it goes into the well certification and so on, like what is the office actually? So there will be a discussion, or it will come up more and more. But maybe Elizabeth or Derek had more inputs on that part.
I just remember, a few years ago when telecommuting and such started to become popular, a decade ago now maybe, and a couple of companies tried it, and then they, pretty much fell apart and went back to, that face-to-face interaction. Of course, talking on a Zoom call, that sounds weird to say, but the reality is that, yes, this is more effective now. We have far more bandwidth than we did. And I know some people have said that that's going to be what makes it different this time. However, it just seems like, business is based on interactions between people, and, why are we doing all of this? If that's the case, we should just all be sitting in a bubble and not even worry about having a nice home or apartment. All right. I mean, where does that end? The fact of the matter is, I do think that buildings are going to, come back to use. This pandemic will go away just like every other one has in the past. But we do have to take heed about what happened. I mean, this is something that will probably happen again. And each time it may be progressively worse. That's just biology acting. So having the kind of technologies that can early detect things, I'm actually putting temperature sensors in our little touch switches. So every time you go near a light switch, it's technically getting that kind of measurement capability ready to go. And what's amazing, of course, about today is that it's so easy to embed those kinds of technologies, and you do it for, $1 sometimes. So I do think that it will, getting systems like what Elizabeth is doing, getting systems like what you're doing, the ability to kind of monitor this stuff, but also I think there's a lot of analysis that's going to be required to figure out which ones are going to be the most effective. And that's really complex, because we're talking about figuring out those soft costs, much harder than just analyzing sensors.
Would everybody agree that if you were sitting with a smart building as a large company and you had a large portion of your employees suddenly have to work from home, that building would be better off and able to save money and to register what's happening in the building and shut down appropriate systems? So in fact, if you had a smart building, you would have been better off during this period than the people who didn't invest in it before this time.
I'll just jump in on that one, because I was like, okay, clever. The COVID happened, like we didn't do nothing. All the buildings were clever, were just like lowering their power consumption automatically, and you had that's it, and that's the way it should be. But it also it's a little bit off topic, but in smart buildings, if you have a really smart buildings, anyone can get access and use it, and will be maybe a shared resource with more people. And then you can fully utilize it across a lot more people.
And a lot of times it's the mechanical systems. For example, the mechanical diversity tends to be the problem in buildings. You can't turn it down low enough. And so, you end up having to cycle, and then someone looks at a sensor pack and they say, oh, look, the building's cycling. And so they will turn it back on again, but there's just not enough load in the building. So, there's advancements in mechanical technologies and the way you design buildings. And the hardest part sometimes is that diversity. It gets back to what I was saying earlier about like a net zero home is difficult, because sometimes you've got a holiday party going on and everybody's there, you're cooking, everything's going on. There's a huge amount of energy being consumed in a short period of time. But that's atypical. Typically what's happening is you got a couple of people, they come here and go. So interesting study done by Sony when they did a DCOES, it was called. It was, they found that 18 to 20 homes, each one having half the solar panel load and half the battery that it would normally need, can actually support each other, because the whole community has enough diversity in it, energy and power source wise, to be able to cover 100% of the loads.
The wider smart play, the smart community. Now, we have another audience question, and I think it's something that I wanted to address as well, which is, that they'd like us to point out some interesting or unique physical solutions, and I'm not sure if, you, Derek, and Sure have absolutely just pinpointed what you're doing that's unique, if you can, start there. But I think what the audience would like is they'd like to hear some very specific things, like, for example, BrainBox and AI is doing some interesting things, or the upward energy that I mentioned in the UK. But Derek, maybe you can explain to them exactly what you're doing with LumenCache, so that they understand, that's one of the reasons I've brought you here, is that's pretty unique by itself. And then also we'll turn to Sure for the same thing, and then discuss some other physical solutions that you've bumped into that are interesting.
Well, thanks. Well, after I did the building automation systems, I did residential. So distinctive audio visual environments was a typical building, home integration company. And, I was amazed at the amount of heat that came off of the rack systems that we had, and the amount of energy that we were, consuming in some of these homes. And I was, so combine all of this together, and the fact that I have 3 boys, that I'm interested in making sure they have a world to live in that's comfortable, made me look at the greater ramifications of what we're doing with energy consumption. And I realized that the infrastructure that we have in place is 120 years old, the power infrastructure. And it was designed for machines that run big synchronous motors 100% all day long, churning out the Industrial Revolution. That has all changed. Everything nowadays is direct current. And I love it when someone says, no, Tesla was right, Edison was wrong, DC lost, you guys are wrong. Even the Tesla cars, just so you know, they are DC powered. There's a battery in there. And then the only AC thing is right at the very end before the motor, because the motor has to spin. That's the only part that's AC. It has to convert it into a rotating signal. So, with everything being direct current, everything needing a little bit of sensors, it just seemed like it was time to say, well, maybe it's a time for a whole new infrastructure. And, the first argument was, well, wait a minute now, my refrigerator, my stove, all these devices that I plug in, they're all AC, so I can't switch yet. And that's what's called technical debt, right? Technical debt is what holds you back from innovation. And at some point, you just have to say, no, I think, either the government can say that it's time to change. And, living in Shenzhen, we see it here all the time. They told everybody you're going to use USB on phones. So that's why you don't have all kinds of different connectors anymore. But in the Western world, there's no person who can just say, we're all going to do this together. So in essence, we had to create a new infrastructure that was palpable to builders who install this whole new infrastructure inside of buildings. So what we came up with is a DC nanogrid. It's ideally made for lighting. The uniqueness and the patent is around the fact that we can adapt to any technology. And thank you for putting the slide up there, the Edison Tesla slide, because that really is the uniqueness of the product. It's when someone says, oh, you're PoE. I'm like, well, no, I'm actually passive PoE right now, but we could be PoE by plugging in a PoE card. Or I could be an XYZ technology that shows up next year. So the point is to future-proof buildings in a way that maintains just a little bit of compatibility so that different vendors and versions of products all have compatibility, because I'm sure you audio video guys are dealing with, rapid obsolescence in technologies. And that's why builders don't want your stuff, right? I mean, when I was an integrator, all the builders were like, yeah, you put that shit in afterwards, excuse me for swearing, but you put all that stuff in afterwards, right? We're gonna put in what's worked for 120 years. And when we're done and you're the homeowner. So what's fascinating to see is how they look at LumenCache and they say, wait a minute, you don't need an app to do this. You don't even need a technician with a laptop to set this up. It's all tool free from that standpoint. It goes in as dumb as the dumb buildings, Elizabeth pointed out, and a dumb light switch. But then all you have to do is plug in a gateway and it immediately transforms into a full lighting control system. And because it has that interaction with the different devices that are at the ends of the wires, it's able to extend the system as you grow, and we can actually get energy data, work with demand management. So, like I said, the example of being able to just throttle back the grid by 10%. Well, 5% of that is, or excuse me, 6% of all the energy in the buildings nowadays for LED lit buildings is lights. And the fact that we can just bring them, well, I was just gonna say, we can actually bring them down 10%. You don't even notice it. You literally don't notice 10% reduction in LED energy, but the grid does. And of course, adding a battery to that means that it's resilient. So.
Yeah, before I ask Sure to jump in, Derek, would you say that your product, is something that, is in the scope of an AV integrator to understand, absorb, and to integrate? Or do you think it's something that requires a technical knowledge well beyond AV areas? I mean, just as an example.
No, I mean, think about our market is the CEDIA type market. I mean, we went to them first because they know how to run low voltage. They're used to it. The only thing that you have to learn is the lighting side of it. In other words, how do you install can lights? And it's one more piece of trade. Most AV guys are used to putting wires in at this level or down, right? Because they put in wall jacks and they put in behind TV. Now you've got to know how to do it in the ceiling. But even that, I mean, we've got training that show like one trip up the ladder, right? Like how can you put lights in and go click, click, done.
Yeah. Okay. Sure. Could you, address, because I think Clever is getting a lot of press lately as being a unique solution. Why don't you tell them what you're doing?
Yeah, I have a pitch next time. We're top 5 in building management in Europe on the build world, so it's good times. But I'm just gonna step back. Like 2009, I was testing smart homes, and smart for me today is a switch in when you exit the house, home or away, and a switch by your bed. It's day or night, and that's a smart home today. And tomorrow they're gone, those switches, and that's truly a smart building. And I've started using autonomous building myself because I'm personally a little bit tired of the smart building. But I'll just tie it to the next question on the physical part. For us, we go in and use whatever is in the building from before, and this is a AV crowd. And the key lessons, or like what you really should think about, is what is the products that you're delivering capable of today. we connected a brand new building with BREEAM certificate and so on, and they had a conference system where we could actually count the people in each meeting room. We could see if there was a coffee cup left on the table, and we knew the temperature. So, and all this information should be open APIs, and then add on from that one. And that's also ties a little bit back to like how much power will all these sensors cost and so on. It's more about, okay, look what sort of equipment you have already in the building. What's the capabilities? What's the use cases you're going to solve with it? And you probably have all the sensors already. We made a smart building out of a dumb BREEAM building without adding one single sensor.
I think the point here is that from an AV industry point of view, you're working in a built environment. Things are changing in the built environment, so you need to know what's going on, because all that data and that sensor, somebody's going to come back to you and say, we want this displayed somewhere, or we want this on a dashboard somewhere, we want this, included. So it's good background. The second question is, are there other areas, like when Derek says go up the ladder, it's not only physically up the ladder, it's in skill adding another rung to the integration ladder if you choose to do so. And there's a lot of different areas in a smart building. You don't have to take them all on unless you want to become a master systems integrator, but to take on a lighting or to take on, I think Sure's area gives people a way to take another look at HVAC, improving that side of a building without actually coming from the traditional, HVAC industry. That's pretty cool, I think. So, along the way, guys, please discuss other, solutions and physical things that you've encountered, that may be interesting to the people. But we have another audience question I wanted to address, and that is, which saves more energy, smart buildings or not driving to work?
That sounds like they get rid of the people in the building. Yeah, I think so.
I think I'd like to start by saying it transfers the energy cost to your home as opposed to to the company's residents. So that it's a law of physics. The energy doesn't disappear. It still pops up somewhere in that. Sorry,
Sure,
go ahead, Derek.
Sure started to answer that when he said, it depends on how smart the building is. If it can shut down certain areas and be more efficient, then yes. However, most buildings are not capable of that today. It also depends quite a bit on the type of energy consumed. If you're using gasoline powered cars, if you have electric vehicles, or if you take metros. So I mean, it's a relatively easy math equation. So if you're interested, Richard, I will post something about that about a month from now, because I think that would be a fun analysis to simply do and say, here's the payback, here's a set of equations, and maybe we'll put a calculator on, and Elizabeth's group can use the calculator for that as part of their set. Yeah. And as far as
one of the other questions, yeah, sure, go ahead, Derek.
Oh, just saying, as far as the AV question, because again, I was an integrator, and I kind of looked at the trends of what was happening. I mean, look at what Apple, Google, all those companies are trying to do. They're trying to say, like, all this smart stuff we'll take on. I don't believe they're going to win, because I think that they don't give it enough personal touch that is necessary, and that's why the audio video integration business will persist. However, it is changing, and you probably already experienced that quite a bit with the smarter TVs, smarter devices, smarter audio. So it's just the kind of thing, like, again, if you're a truck driver or a taxi driver, you may want to be looking into other fields, because eventually, or a factory worker for that matter, all of those types of fields are going to change. So if you're a factory worker, you want to get into learning how to do factory automation and maintenance and operation and engineering. If you're an AV guy, I think you need to kind of start looking at, what are the other things that we can do from a custom installation standpoint to be able to earn money. All new buildings will have lights, guaranteed. But if you notice, there's a reduction in the number of TVs because a lot of people are using their portable screens. So, it's definitely a field to look into.
Yeah, I think there's a reduction, in the in the number of screens in the home, I would argue that for the commercial buildings, more screens are being needed because of the data being generated and what people want to do with it. But that leads us to this other question. So since, you know, we're in the AV industry, this is a gentleman from the audience, you know, it seems to him, you know, that the, you know, what aspects, you know, of the AV systems are relevant to the energy, because it seems to him that they're relatively immaterial. I think that's my fault, because I put up the slide saying the amount of energy compared to lighting and to, you know, heating and cooling is less. But I think, like you were saying, Derek, you know, those racks are burning hot. You know, I think there's energy issues inside of the AV equipment that have to be addressed as well.
I'll give you
Gentlemen
two.
and ladies, you know, if you have anything to.
Yeah, I'll give you two quick examples. One of them is doorbells. Doorbells consume 2.7 watts. If you multiply that out, it's, I don't know, it's like 170 million barrels or 1,000 barrels of oil per year. It's a ridiculous amount of energy. And the same thing goes for all of the standby power in all these devices. So you know how we had vampire loads and talking about unplugging things? That's yet another one of the features of LumenCache where, for example, it has standby power built in. Having standby power ready to go at 12 volts as opposed to dropping it down from line voltage 220 or 110 is far. And so you have, you know, all of these things added together because we're breaking the old mold of standards. So, and all of those things do add up. If you notice, there's miscellaneous electrical loads, MELs. And there was a study done that I was part of a couple of years ago from California Tech that had to do with, you know, how do all these standby devices, when you can unplug them, how much savings? And all of that has been written into the codes, by the way. So, you know, what happens in California tends to shift across the rest of the world. So I think that's another thing to be prepared for, and having these buildings already ready to go, wired up with this capability, to me is the biggest jump forward.
I'll just jump straight in on collaborative building. When you put in, when you make an autonomous building that takes care of itself, like in the perfect situation, then the AV equipment would be connected to the counter of people in the building and so on, and they would go from standby to totally shut down, and you would be able to boot up the system, like it would go sleeper and sleeper, the less people or where you are. So it's all about collaboration in the building with open APIs and yeah, just talk together on it. But it's back to on the AV part. It's look at the products today and then see what's the nearby fields. You mentioned light. With the HVAC is also one part. It is data management now as well. Yes, there's some filter changes and so on, but the whole building gets connected. Everything in the building is connected. So if you're only on a narrow AV part, then look a little bit further, broaden your scope.
It's kind of like why Nest made smoke detectors. They made smoke detectors because the thermostat's in one place in most homes. Smoke detectors have to be where the people are. So if you're wondering why that was the first part that they made, it was to get that sensor information back into the HVAC system.
And I think AV, you know, we tend to think in perhaps more limited terms, but with digital signage, you know, now in the corporate lobbies, the wayfinding, you know, with the conference rooms, and now the need for the remote work from home technologies, the emergency and the broadcast systems that are in place in the building for communication. There's a lot of other aspects to AV, but it all happens inside the built environment. And as I say, when that built environment changes, you need to know what other people want from you or expect from you, and there may be opportunities to reach out and to grab other parts of the integration puzzle if it you know fits in with your particular company, or if you want to go out and build the skills. We have, I think, almost out of time here, but maybe as we finish up, if you want to make a closing statement, Elizabeth, I'm going to turn to you about the certification. You know, how you feel that it might benefit, you know, because you're offering it not just to, you know, to the buildings, but you're offering also to help, I think, you know, get trainers and people that can help with the certification. Maybe you can explain that quickly in our last minute.
Yeah, so we have a certification program where part of it is put through a quantified system that goes through an algorithm to assess different aspects of it. We also have a kind of a qualitative point where people actually can explain the solutions in their building. You know, one thing that we didn't want to do was have a checkbox situation where, you know, we all know about different scenarios where if you move a wall 2 centimeters this way, somehow it's certified, and if you don't, then it's not. So we really wanted to say sometimes the wrong train gets you to the right station, and celebrating the different solutions. We really think there are a lot of different solutions for achieving a smart and highly efficient, highly healthy, safe, sustainable, high-performing building. And so with that, we have our assessor program, where we have assessors who are experts in the workplace, actually looking through the qualitative aspects of this. We have 3 assessors for each building. They look through these answers, and they give their feedback and their recommendations for moving forward, as well as their assessment of the solution. So we have that program. We're also bringing in a huge network. We can partner with PropTech communities, with real estate companies. We really want to bring together the world of smart buildings, which is such a wide variety of industries, and share knowledge, get talking, make connections, really move things forward. Our goal is really to have better, smarter buildings as fast as possible. And I think sharing knowledge, really putting stuff out there, and having a great measurement tool to do that. So that's what we're moving forward with.
All right. Thank you, Elizabeth. We're out of time here, but I want to give Derek and just a very short, you know, way to sum up, if you'd like to give a final message here. Derek, what would you say to these AV people about, you know, getting into, you know, some angle of the smart building, you know?
Certainly. Yeah, I think, you know, now is a great time to be looking at all the different technologies that are available that will have some level of control. Products like yours are going to be more and more prevalent, and they're going to add significant amount of value. And you guys are the ones that are putting that infrastructure in place. And certainly visit, you know, Linden Cache, and you know, take a look at lighting if you're not already putting it in. It's not that difficult, and there will be many other applications beyond lighting. Once you have a smart infrastructure in place, we can solve 5G inside of buildings. You already do it with wireless access points. Audio systems, making you know, each light or switch location, for example, having a microphone, begins to, you know, you start to see how having a smart infrastructure like this will solve many of the challenges that you are facing right now.
Okay, sure. You got your last comment before we're running on overtime.
Yeah, it's like Clever just connects to what's in the building already, and then you can pay it off with the energy savings that you're already doing. So for the installers on AV, and it's look at what your product, how they connect to the rest of the building, see what other services is possible to offer, and then Clever is can fit right in, and you don't need all the competency for it, and like for all the HVAC part, because that it does the job for you. So you can easily add that as a silo or another as an extension to it. So that's short.
Well, that's short enough, and I want to thank everybody for attending. And I want to just say thank you to all our speakers for joining us and bringing in this expertise, you know, from different parts of the world and from different backgrounds. Thank you, everybody. I'm going to turn it over to the AVIXA organization.
Thanks, Bob, and thank you to all the speakers. Also, thank you to our listeners for joining today's webinar, Smart Buildings Power Hour on Energy. This recording will be available on avixa.org/webinars within about 5 business days, and your 1 RU credit will be applied to your transcripts within about 5 to 7 business days. If you have any trouble, please contact webinars@avixa.org. A huge thank you to Bob and guests for providing insights into the role integrators can play in engaging occupants. We hope you enjoyed. Have a great day. Thank you, everyone.
Thank you.
Thank you.
Bye-bye.
Bye.
Well,